you're sitting at your desk, probably supposed to be studying. You open your math book and there it is, derivatives and integrals. You sigh because you recognize the formulas, but if someone asked you what they actually mean, no idea. You scroll through old notes, you see slopes, areas, curves, random letters, and your brain goes, okay, I'll memorize this and just forget it right after the exam. And maybe you've even thought, I'm just not a math person. But here's the truth, nothing is wrong with you. You were just taught symbols before the ID, because derivatives and integrals aren't advanced. They're actually very simple questions. A derivative asks, how fast is something changing? An integral asks, how much is there in total? That's it. No magic, no secret talent, no math genes required. So in this video, I'm going to explain derivatives and integrals as if you never ever seen them before, slowly and calmly in an ASMR way, of course, with examples that make sense. No stress, no pretending this is easy, just math that finally clicks. So let's start. So before we get into this video, please leave a like and subscribe to be an OG and join the educational ASMR cult. So firstly, what is a derivative? A derivative answers one simple question. How fast is something changing? That's it. And a real life example is that imagine you're in a car. Distance equals to how far you've driven. Time equals to how long you've driven. And speed equals to how fast the distance changes. Speed is a derivative. So when we say the derivative of distance is speed, we mean how quickly is distance changing right now. Imagine a graph. The x-axis equals time. The y-axis equals distance. The derivative tells us how steep the line is at one exact point. Steep line is big derivative. Flat line is that derivative equals to 0. And going down equals to a negative derivative. So if we have f of x equals to x squared, the derivative is 2x. And at x, when x is 1, the slope is 2. When x is 3, the slope is 6. So bigger x is a steeper graph. And the function grows. And the derivative tells us how aggressively. Now for a quick practice. Please pause after each if you feel like you need to. So firstly, the derivative of f of x equals to x in cubic. And answer in 3, 2, 1. Second question, f of x equals to 5x. And Answer in 3, 2, 1. Third question. F of x equals to 7. Answer in 3, 2, 1. This is because constants don't change emotionally nor mathematically. If derivatives ask how fast is something changing, then integrals ask how much is there in total. An integral is adding up infinitely tiny pieces, like collecting sand grains. A real-life example is, imagine rain is falling. Rain speed equals to derivative, and the total water in a bucket equals to integral. The derivative tells you how fast water is coming in. The integral tells you how much water you have collected. They are opposites, but also soulmates, like me and you. Is this Shad? Is this Riz? An integral is the area under a curve. Above the x-axis equals to positive area. Below the x-axis equals to negative area. So if we have f of x equals to 2x, then the integral is the plus c is just we don't know where we started. And here are some quick practice questions of integrals. Pause the video if you haven't answered them, but answer in 3, 2, 1. So this is the most important part. Derivatives and integrals are like up and down, on and off, undo and redo. So watch this magic. Start with f of x equals 2, and the derivative is, whilst the integral of that is, we're back. They kind of cancel each other out. So this is the big idea. Derivative breaks change into speed. Integrals rebuilds speed into total amount. If you understand this, half of calculus becomes emotional support, and you will crash those exams. Now let's clear up something important. In math, we don't randomly multiply the x-axis and the y-axis. We only multiply them when we are measuring area. That's the key. So derivatives, why we do not multiply. A derivative measures rate of change, not area. So here's what we are measuring. X-axis is change in x, y-axis is change in y. We are asking how much does y change when x changes a tiny bit. That's a division, not a multiplication. So for the unit logic, if x is in seconds, y is in meters, then the derivative has units meters per second. x-axis and divide with it by x-axis. The units, of course. For example, distance versus time graph. And the derivative is the speed. We are not calculating a rectangle, we are calculating how tilted the line is. And now integrals. They are different, and this is why we do multiply, because an integral measures area, and area is width times height. This is where multiplication happens. The unit logic that makes everything click. Let's say x-axis equals to time or seconds, y-axis equals to speed, meter per second. If you multiply them seconds times meter per second, you get meters. Boom. That's distance. So when we integrate, we are doing width on x-axis times height on y-axis, and we get a tiny area. Then we add all those tiny areas together, and that's the integral. And here's the clean connection. Derivative is y divided by x. Integral is y multiplied by x. Now we are doing some exam style questions. So firstly, we will do some non-text ones. So answer. Answer in 3, 2, 1. And the second one. Answer in 3, 2, 1. You didn't forget the plus C, right? And now let's move on to 2 text questions. So first one. A particle moves along a line. Its position is given by this formula. A. Find the velocity. B. Find the position at t equals 2. Answer in 3, 2, 1. Now for the second question. The velocity of a car is. Find the distance traveled in the first 5 seconds. Answer in 3, 2, 1. so much for watching this video about derivatives and integrals. I hope you enjoyed it, and most hopefully you learned at least something, and I would love to if you could give me a like and subscribe, and please comment if there's any other area or topics you want me to cover in the next video. I have some in mind and some in my list because I post a video fortnightly. So be quick to write in the comment what you want and I will put that on my list. If you think it's a good idea to make a part 2 of this video where I explain the rules perhaps, or if you have any other ideas in mind, just tell me in the comments. I will always be here and listen to your opinions. So thank you so much for staying this long. You must have a really good attention span.